Hey guys, Mr. T here. This is another video. This one is on solution of simultaneous linear equations by substitution. So solution by substitution you use when one of the equations is given with x or y as the subject. So you have x or y all by itself on one side of the equal sign. So for example, x is equal to y plus 3 or y is equal to x plus 3. You wouldn't use this if it was x plus y is equal to 3, because x and y are both on one side. You could rearrange it, yep, but this may be a quick method if you notice that one of your equations is given where x or y are by themselves on one side. The substitution occurs when that variable, which has been the subject, so in this case x is the subject of the equation, and x is equal to y plus 3. So it occurs when the subject is put into the other equation. This causes the other equation to be expressed only in terms of one of the variables, x or y. So as to show how this works, because that can be a little confusing just in words here, let's solve these simultaneous linear equations by substitution. First thing to notice is the first equation is given with y as a subject. Y is equal to x take 3. Y is the subject of the formula, x take 3. The other equation is not written in that form. You've got x and y on one side. Now, because y is the subject of that formula, it means y is equivalent to the other side. Y is equivalent to x take 3. So that allows me to substitute x take 3 into the other equation, because we know y is equal to that. Y is equal to x take 3, so if y is equal to x take 3, I can replace y with x take 3 in the other equation. I'm substituting x take 3 into the other equation. So it would look like, and I've already used blue, so it would look like this: 2x plus 3 times by what we said y equals, which is x take 3, equals 16. I've substituted y is x take 3. I've substituted that and replaced it into the other equation wherever y was. So now notice this equation now has only one variable, so you can find the value of this variable using algebra. There's no y's here anymore. We replaced y with a statement that involved x instead. So we can use algebraic simplification and expansion to get rid of everything and solve for whatever x is. So let's do that now. 2x plus 3, x take 3 is equal to 16. I have brackets here, so according to Bedmaster, I need to deal with those first. These brackets have a variable, a couple of terms inside the brackets, and a number on the outside, so I need to expand them. It's expanded by multiplying the number on the outside by the first, number on the outside by the second number. So 3 times by x is 3x. 3 times by negative 3 is negative 9, equals 16. Now I need to use algebraic simplification. If I've got 2 x's and 3 x's, I have 5 x's in total. Take 9 is equal to 16. 5x. The opposite of taking 9 on one side, taking 9 is adding 9, and I need to do that on both sides to keep it balanced. So I'll draw the balancing operation in brackets. So that working out comes to 5x is equal to 16 plus 9, 25. Not there yet. I want to work out what x is. I need to get rid of the times by 5. The opposite of timesing something by 5 is dividing by 5. Perform that operation on both sides. So 5 divided by 5 is going to be 1, so I've just got 1 times by x left on the left. And 25 divided by 5 is 5. So my solution so far is x is equal to 5. Now if you remember from the previous video, the solution is x is equal to something and y is equal to something. So we've only got half of the solution. You must then substitute this known variable into one of the equations to find the value of the remaining variable. We only know what x is right now. We need to substitute that known value of x into one of the equations to find the complete solution. It can be any of them. I'll choose the easier one. I'm going to substitute x is equal to 5 into y is equal to x take 3. Y is equal to x take 3. if we know that x is equal to 5, y is equal to 5. Take 3. There's nothing else I can do with those brackets, so they can just be ignored. Y is equal to 5, take 3, 2. We can double check by trying to substitute it in the other variable. 2x plus 3y is equal to 16. 2x plus 3y is equal to 16. We know that x is 5, so 2 lots of 5 plus 3y is equal to 16. 10 plus 3y is equal to 16. Opposite of positive 10 is taking 10. Need to do that on both sides to balance out the equation. 16 take 10. 10 take 10 is 0, so all I have left on the other side is 3y. 16 take 10 is 6. Opposite of 3, multiplying by 3 is dividing by 3. Divide by 3 on both sides. Cancels down to 1y. 6 divided by 3 is 2. They're both the same. That confirms that the solution is, therefore, x is equal to 5 and y is equal to 2 is the solution. So that's an example of solving simultaneous linear equations by substitution. Hopefully that helps you out, and I'll see you in the next video.